Okay, now that you've worked on solving or factoring quadratics, now we're going to talk about graphing quadratics. We're going to talk about three different methods. There's the basic, just table method. Here you have a quadratic, here you have a table of values, and you select the x values to plug in, and when you select an x value, you plug the x value into the function everywhere there's an x. So if we chose where x is 0, you'd plug 0 into there, into your calculator, or just using your brain. Simplify that. So where x is 0, well, 0 squared is 0, plus 6 times 0 is 0. 0 plus 8 is 8. So right up there at 8, we know there will be a point. And then you do the rest of the table. You might pick some values to the left of 0 and maybe some values to the right of 0 to get a general idea of what the graph. So -2, make sure you label the graph too. That's an important, a very important feature. So you plug all those values. Make sure if you're using a calculator, you must use parentheses around the values, especially the negative ones, or you'll actually get incorrect y values. Okay, so that is just kind of the basics of the table value. Let's talk about another table method. Now there's the factoring method. So if you have this function right here and you were to factor it, well, factors of 8, 2 and 4, 2 times 4 is 8, 2 plus 4 is 6, so it meets that criteria. And x squared, you've got x and x here. Well, now to find the factors, you use the 0 property. X plus 2 is equal to 0. Subtract 2 from both sides, so x is equal to -2. Or you could say, oh, to 0 out 4, it's the additive inverse. So the opposite of 4, which is -4. So there's a point. There's a point. That's not being very cooperative. And then 2 times 4 is 8, so we know there's a point. So 2 away from 0, we go 2 away from -4. Remember, a quadratic is symmetrical, and halfway between 2 and 4, there'd be this thing called the Axis of Symmetry. Now you could sketch the graph and it'll look something like that. And if you're not sure, halfway between -4 and -2 is -3. Plug -3 in as the center value. And we know at 0 we're up at 8. And it looks like at -6 we're up at 8. And at -4 we're at 0. And at -2 we're at 0. So you just plug -3 into the function to figure out what the vertex, what the lowest value is right there. All right, and finally, one of the last methods that we're going to look at is the vertex method. That's when it already tells us, this is called vertex form for a reason, because if we zero out inside here, so the opposite of 3 is -3, so where x is equal to -3, and since this is on the outside, we don't have to worry about taking the opposite, where y is equal to -1, so at -3, -1, so -1, -2, -3, -4, -5, so at -3, -1, I wish this was more helpful. -1. So right there, we know that if that's the vertex, that means that this will be the axis of symmetry. So if I put 2 values over here into a table, 2 values of here into a table, we're going to know about what that graph looks like. All right, let's try a specific one. So sketch the graph of each function. If you need to, use a table of values to graph specific points. Well, here we have a function. The first thing that you could ask yourself, does it have any factors? Can you factor this function? Because sometimes that's easy. And also, where would the y-intercept be? Well, we know the y-intercept is always going to be when x is equal to 0. So this constant right here will always be, so right there we're going to type in, 0. We're going to be down here at -3. And it might be a good idea to just put a point right there so you don't forget about it. Okay, then you could do a table of values. You could say -1, -2, 1, 2, and plug that into the function. Or you could say, I wonder if this is factorable. Well, factors of -3 that add up to +2. Well, 3 times -1 is -3, and 3 plus -1 is +2. Oh, and then you could put your points on the x-intercepts, because these will be the x-intercepts. So where x is, what's the opposite of +3? -3. So where x is equal to -3, remember this is the x value, and where x is equal to +1, that's our other x value. Well, if these are the two intercepts, halfway between them, right here at -1, so right there, this will be our vertex point. So when we plug -1 into that function, well, -1 squared is 1. 2 times -1 is -2. Subtract 3. So +1 subtract 2 is -1. -1 subtract 3 is -4. So at -1, -4. Okay, so and graphs are symmetrical. So if this is one to the right, 1 up, I know I can go 1 to the left and 1 up. And now I have a lot of points that where I can just sketch. Remember, when you sketch this, you do not do this. That is not the graph of a quadratic. It has to be a smooth curved line. All right, that's it for using the table, factoring, and using y-intercept values. So it gives you an idea, a couple different ideas of how to sketch the graph of a quadratic. All right, that's it for this one.